Hi everybody, today we are going to talk about the formal definition of a limit. And let me just warn you right before we get going, this is pretty confusing. So don't be afraid to kind of pause and rewind a little bit, maybe watch the video a couple of times to make sure that, that all this makes sense. All right, so let's start off with a limit, all right? So let's say that I was asking you for the limit as x approaches 1 of 2x plus 3. Now, when x values are approaching 1, then 2 times those x values will be approaching 2, and 2 plus 3 is approaching 5. So it seems pretty reasonable that this limit is going to end up being 5. And that is a very informal way of going about that limit. And what we want to do here is formally go about convincing everyone that this limit does in fact equal 5. And the idea to keep in mind here is that when I look at a limit as x approaches 1, x gets close to 1 but never actually gets to 1. So how am I going to convince you that the limit is going to get to 5 if x never actually gets to 1? So that's worth writing down. And the way that I'm going to say this is that if x never gets to 1, how am I going to be able to show you that the limit gets to 5? And the way that we will do this is, rather than showing you that x gets to 5, we're going to show you that x gets really, really close to 5. And the process is this. I'm going to say that you will give me a tolerance. And in my first example, I'm going to say that you give me a tolerance of 0.01. And that is something that will change in all of these problems. But for right now, that's a pretty good tolerance. And so what you're saying is, all right, if you can show me that this limit gets to within 0.01 of that limit 5, then I'm going to be convinced that this limit is in fact 5. So what I mean is that if I can show you that f of x minus 5 is less than this tolerance for values of x that are close to 1, one being the value that x is approaching, then I will have convinced you that this limit does in fact equal 5. And there's no way that you can hear this the first time and have that make sense at all. But let me remind you of a couple things from algebra. So from algebra, if, for example, you were looking at an absolute value inequality, maybe it was x minus 3 is less than 2. The way that you do this in algebra, if it's an absolute value that is less than a number, you would take the argument of the absolute value and sandwich it in between the number and the negative of that number. And then I would add 3 to all 3 sides, and I would get that x is bounded above by the number 5 and bounded below by the number 1. And if I graph that for you on a number line, let's see, I would have the number 1 and the number 5, and I would say that it has to be in between those two values. Now, the thing that I want you to recognize here is that in this answer that I got between 1 and 5, 3 is exactly in the middle, and 3 is that number that's right there. And it turns out that the distance between 3 and both of the endpoints is 2, and 2 is the number that I needed the absolute value to be less than. Now, this is not always going to be the case. It will actually always be the case as long as the argument is linear and the coefficient of x is 1. So, for example, if I asked you for the absolute value of x plus 1, was less than 3, I could graph that solution for you by starting at -1 and then moving up 3. 1, 2, 3. So that'd be 0, 1, 2. So this would bring me up to 2. And then go down 3. 1, 2, 3. So that'd be -2, -3, -4. That would end up being the answer to that inequality, right? So if I have an absolute value and what's inside the absolute value is linear, where the coefficient is 1, then that value that it has to be less than is almost like this tolerance that I have been talking about. Okay, so if I go back up to where I just was, then you can see that that's what's going on here. I want to say that my f of x value is within 0.01 of 5, right? Okay, so let's look at a little bit of algebra with that. So I asked the question, when is f of x minus 5 going to be less than 0.01? And you'll recall that f of x was 2x plus 3. So this would become 2x plus 3 minus 5 in absolute value is less than 0.01. And now I'm just doing a little bit of algebra. That's going to be 2x minus 2 is less than 0.01. And then this is good. I'm going to do this because I have done this before. You don't necessarily know why I'm going to do this computation. You just have to check and make sure that it's okay. I'm going to factor out a 2, which is going to leave me with x minus 1 in the absolute value. And that's going to be less than 0.01. And then I'm going to divide both sides by 2. So I get that the absolute value of x minus 1 is going to be less than 0.01 divided by 2, which is 0.005. And I'll also ask you to recall what was written up at the beginning was that we were looking at the limit as x approaches 1 of 2x plus 3, and we were trying to show that that was equal to 5. So what just happened? You gave me a tolerance that was equal to 0.01, and then I let f of x minus that limit be less than 0.01, and then I did a bunch of math to get all the way down to this point, and I end up with a tolerance on the value of x. So here, since x minus 1 is less than 0.05, like I said in my example reminding you from algebra, if 1 is right here, then I could go up a distance of 0.05. That would be to 1.005, and then down 0.005, which is 0.995. This gives me a range of values for x. So what I can say is that f of x is within 0.01 of 5. So again, 0.01 is your tolerance and 5 is the value of the limit when x is within 0.005. This is a tolerance that I got from your tolerance of x equal to 1, and x equal to 1 is the value that the limit was approaching. Okay, I'd like to do that again with a slightly different limit, because you're going to notice here that the computation is really not too bad for a lot of these examples that we are going to be looking at. Let's say in example 2 that I want to look at the limit as x approaches 2 of 3x plus 2. Well, let's see. As values of x approach 2, 3 times 2 is going to approach 6. 6 plus 2 is equal to 8. And again, we are going to stay with the same tolerance of 0.01. So where do I start? I start with f of x minus 8, the limit in absolute value, less than that tolerance of 0.01. Then I'm going to just do some math. F of x is 3x plus 2 minus 8. That has to be less than 0.01. Then this becomes the absolute value of 3x minus 6. less than 0.01. I can factor out a 3 to get x minus 2 is less than 0.01. And I want you to recognize that what's left is x minus 2, and it is no coincidence that we had x approaching 2 in our limit. And so that gives me that x minus 2 in absolute value is less than 0.01 divided by 3. Now that's going to end up being a repeating decimal, so I'm just going to leave it like that for a moment. But this is the answer that we are looking for. So I can say that f of x equal to 3x plus 2 is within the tolerance, 0.01, of the limit 8 when x is within this tolerance that I just got, 0.01 divided by 3 of x equal to 2.